Hey everybody, I wanted to talk to you about a method of rewriting and keeping track of your combo circuits that is one that we haven't tried much in class, only touched on briefly, but I think for some of you it might be helpful for your packing and unpacking of combo circuits. We're going to use this combo circuit schematic that we've used in our class a little bit and in our handout some. With a different reformatting here that Amy and Laura like to use a lot, and they're really good at this stuff, really well traveled with all of it. So we're going to try it out here and see if it clicks for some of you. We're going to add, in addition to reformatting this, we're going to add a notes section for ourselves, and I'd like us to color code those notes. We'll see why in a bit, to help us retrace our steps for the unpacking process. So over here, we have our voltage, and we're going to keep that the same from our starting point. Use black for the reformatting the schematic. We're going to come out here from the left, just like that, with like we're coming out of the negative battery cable there. First thing that we see coming out of this is that we hit this 10 ohm resistor R1. So we're going to, instead of putting the squiggly resistor, we're just going to actually write R1 here, 10 ohms. And then we're going to start coming out the other side. On the other side of R1, you see that it splits two directions, one way up to R2, one way down to R3. We're just going to do the same thing. Just split two directions up to R2 at 10 ohms and down to R3, also 10 ohms. Out of the other side of R2, we're just going to keep traveling there. Doesn't matter really which one we follow, R3 or R2, but let's go ahead and just keep going in R2 here. We just came in on the line side of R2, coming out of the load side of R2. We see ourselves split again down here into the line side of R5, line side of R4. So we're going to do the same thing just in a shorter way here. I'm going to come in the line side of R5 at 10 ohms, and the line side of R4 also at 10 ohms. You see down here that the load side of R5 converges with the load side of R4 on the other end, so we're just going to do the same thing. Just going to converge together there. It comes out that end. And then at the end of that, reconvenes down here with the load side of R3. You notice there's nothing else on the load side of R3, so I can just keep on going all the way to the end and meet up on the load side of R4 and R5. And that is the end of our circuit. We're just going to write it upward here with a little plus sign signifying the positive terminal on the battery. And that's our entire circuit rewritten there. You might notice that it's maybe a little bit easier to see our order of operations this way, maybe not just yet, and if it's not yet, then it'll be clear soon. What strikes me, or what sticks out to me rather, is that it makes it pretty obvious that I've got to get these two in parallel with each other, and then these in series with each other, and finally these in parallel with each other again. So we're going to write out this order of operations here. One thing we haven't done in class is color coordinate our series combinations and our parallel combinations, so I want to start doing that now, step by step. So we see that the first step that we have here is to combine R4 and R5 in parallel. We're going to call our parallels blue And up here I'm going to write step 1, R4, PAR for parallel with R5. And in the parentheses, I'm going to write what that creates, a new resistor named R45. And down here I have R4, 5, with an ohmic value of 5 ohms. Next step, I see that I'm going to have to combine this new resistor in series with R2, with the 10 ohm R2 over here. So R4 and 5 and R2 are going to have to go in series with each other before I can do anything with this. So the next step, in series, we're going to write our stuff out in red. That's going to be R4, 5 in series with R2. Alternatively, R2, SER for series with R4, 5. And again, that new resistor that we create is now R2, 4, 5. And we'll write that in at the end of this here, R2, 4, 5, with an ohmic value of this 10 ohms plus this 5 ohms combined in series for 15 ohms. Great. And it may also be helpful, especially in the more complicated ones, to just next to its associated number, just write that's step 1 here, that's step 2 here, just to give us a little bit of a correspondence between our order of operations for when we unpack it. Our next step that we see is we have, now that this is established and this is established, now we have two values, this here, R245, that can go in parallel with R3. So parallel, we're doing blue. We're going to do step 3 is R3 parallel with R2, 4, 5, with a new resistor called R3, or rather, my apologies, R2, 3, 4, 5. Great. And we'll just write that kind of right in the middle here. R2, 3, 4, 5. Combining this 10, this 15 here in parallel. I think that's 6. Let's double check. 10 times 15 equals 150 divided by 25 equals 6 ohms. And lastly, we have our 6 ohms now that's in series with R1. So our last step here is to combine R2, 3, 4, 5 in series with R1. All our stuff that's in series we're writing as red. So R1 series with R2, 3, 4, 5. Our new resistor, R1, 2, 3, 4, 5. Alternatively to that, since it's our last step, we can go ahead and just call this one RT. That RT is going to have a value of R1's ohmic value combined with in series with R2, 3, 4, 5's for an RT, our total of rather 16 ohms. Great. And like I said before, if it's helpful at all, we can include the steps here. So this was step 3, you may recall, up here. And then the last step, step 4, was right here. All right, so when it comes to unpacking this, we have a ET that was established up here of 100 volts. And since what transfers over, what stays the same for all of our series circuits is current, we're going to need to establish our total current so we could transfer it over to the most recent step that we took. And when we're unpacking, we always want to retrace our steps in the exact reverse order here. So let's go ahead and find out what that would be. We take our 100 volts, divide it by our 16 ohms, and end up with 6.25 amps. Will be our IT. That 6.25 amps goes to the things that made up RT. That's our most recent step. So the two things that made up RT were R2, 3, 4, 5, and R1. Each of those gets 6.25 amps. So R1, 6.25 amps, and R2, 3, 4, 5 get 6.25 amps. This R1 has two values, so we can figure out any third value that we want at the end of the day. I'm more concerned about retracing my steps here at step 3, which is the most recent step before that. We'll just check off this step now that we got it done. Move on to step 3. The things that made up this were, again, in blue. They were in parallel. So we want to be able to find the thing that transfers over in parallel with its which is voltage. And we have the components that we need to do that over here. We've got our 6 ohms, our 6.25 amps, 6.25 times 6 equals 37.5 volts. And that's going to transfer between the components that made up this resistor, which would be R245 and R3. Each of those get 37.5 volts. Again, R3 has two components if I ever need them again. That's one of my original resistors, which are all in black, you'll notice here. I'm just going to leave those two components there in case I need to solve for anything later, whether it's current or power. But I'm more concerned about retracing my steps, checking off 3, going on to step 2. And I have what I need over here at this step 2, this R245. I have two components. That means I can find out a third component, which I need because what made up this resistor 245 was done in series between R2 and R45. So I need to find out the current of those there, and to do that, Ohm's law, 37.5 divided by 15 ohms equals 2.5 amps. I'll write that down here, 2.5 amps. That 2.5 amps goes to the things that made up 245 here in step 2. So it would be R2 and R45 each get 2.5 amps. 2.5 amps at R2 and R45 gets 2.5 amps. R2 was one of my original resistors. It's got two components if I ever need it to find out voltage or power later, but I'm just going to keep retracing my steps for unpacking this. I finished that step 2. Now I'm on to step 1, figuring out what made up my R45. See, this is in blue. This was done in parallel between R5 and R4. So I'm going to figure out my voltage using these two components here. 2.5 times 5 equals 12.5 volts. volts. And that 12.5 volts goes to the two components that made up R4, 5. So R4 and R5 each get 2.5, or 12.5 rather, volts. And now all of my original resistors, R1, R2, R3, R4, R5, all of them have at least two components. And if they have at least two components, then I can solve for any third component in this circuit. Thanks for watching this, and I hope it's helpful. Email me, please, if you have any more questions or any details about this that you wanted to go over some more.